In this video, I want to have a look at some problems involving rates. So we're going to jump straight into a few examples. Our first one says Jess earns $96 for working a 6-hour shift. And there's 3 parts to this question. The first one says express this as an hourly rate, so in dollars per hour. So to do that, we know that she earns $96 for working 6 hours. So if we want to write it in dollars per hour, we want to know how much she earns for working 1 hour. So we're going to go 96 divided by 6, and that's going to give us 16. So she's going to earn $16 per hour. All right, part B says, how much would Jess earn in a week where she works 20 hours? Well, we know now that she earns $16 per hour. So if she's working $20, we're going to go 16 times those 20 hours, and that's going to give us $320 over that whole week. And part C says, how many hours would Jess need to work to earn $600? So that's $600, we're going to go 600 divided by the $16 per hour, and that's going to tell us how many hours she needs to work. So 600 divided by 16, and that's going to give us 62.5. So she's going to have to work 62.5 hours to earn $600. Our second example says 5 kilos of apples cost $22.50. Part A asks us to express this as a rate in dollars per kilo. So part A. So we've got $22.50 for 5 kilos. So that's going to go $22.50. And to figure out how much it costs for 1 kilo, we're going to divide that by 5. So we'll end up with $4.50 per kilo. So each kilogram costs $4.50. For part B, it then says how much would 2 kilos of apples cost. So if each kilo is $4.50, to find out 2 kilos, we'd times that by 2, and we'd end up with $9. And part C says how many kilos of apples could you buy for $40? So we're going to divide that $40 by the $4.50, and that'll tell us how many kilos there are. So 40 divided by 4.5, and that's going to give us about 8.9 kilograms. So that's rounded. So almost 9 kilos we could buy for $40. So we've just got one last example, and it's slightly harder this time. So our question says Matt drives 450 kilometers and uses 30 liters of petrol. So when we're talking about how fuel efficient a car is, we actually don't measure it in liters per kilometer. We measure it in litres per 100 kilometres. So we're saying how many litres does a car use over 100 kilometres. So when we're expressing it as a rate, we're not just going to go our 30 divided by 450, because we don't want to get this down to 1 kilometre, we want to get it to 100 kilometres. So 450 kilometres is 4.5 hundreds. So to turn this 450 into a 100, we have to divide by 4.5. which means we're going to divide our 30 by 4.5 as well. So to express it as a rate in litres per 100, we go our 30 divided by 4.5. And that's going to give us approximately, if we round to 1 decimal place, 6.7 litres per 100 kilometres. So roughly every 100 kilometres they drive, they're using 6.7 litres of petrol. So part B then says how many litres of petrol will Matt use driving 780 kilometres? So 780 kilometres, we want to know how many hundreds that is. So that would be 7.8 hundreds. So we know it's using 6.7 litres for every 100 kilometres. So we're going to go 6.7 times that 7.8. And that's going to give us 52.26 litres. So that's how much petrol they're going to use over that 780 kilometres. And part C says how far can Matt drive on 16 litres of petrol? So we're going to go our 16 divided by 6.7. But if we do that, that's going to tell us how many hundreds of kilometres we've travelled. If we just want to know how many kilometres we've travelled, we're then going to have to times that answer by 100. And we'll end up with about 239 kilometres if we round that to the nearest whole number. So those are just a few examples of problems involving rates.